almighty. Phone has rang like crazy today. Okay, let's see if we can get through the intro segment of this. So, this is a Snowcap Technologies Comp 24 pill. And I don't know where he got this heat sink from, but it's actually pretty impressive that's in here. This has got 24 Toshibas in it. This was brought up to me by one of my friends out of Oklahoma. And he showed up here with 3 amplifiers. This one, a 32 and a 96. 96 pill is going to need a lot of help. Hold on a second. This is the 96 pill, which we're going to have to strip down and change a bunch of stuff on. But that's not what this video is about. This is what this video is about. Now, after looking at that 96 pill, I think you guys can all appreciate how excited I was when I opened this thing up and seeing it didn't look like that 96 pill. This is actually fairly well organized. So there's 2 eras of solid state building in my mind. There's actually 3 or 4, but you have 2 styles of building, which are really commonly recognized in that building world. You have the messenger style of building. Okay. Well, there's 3. We'll go with 3 for the moment. You have the messenger style of building. You have the Dave Made / Motorola Engineer Guide Handbook style of building. And you have the stickman style of building, which is all inductor, combiners, and splitters. This is a hybrid box. These are our input splitters. This is our output combiner network, which then go to this network. So this is individual 2-pill sections, by the way. Individual 2-pill, individual 2-pill. Combined. Then we drop it down to 50 ohm coax, and then we do the final stage combining over here on this side of the board. And then this side of the board's all combined here. The signal that comes out of that then goes to a messenger style of combiner, and then it goes out. So the story I have been told, and let's face it, this box has seen a few miles, right? I mean, it just has. Let's just walk in here. And let's take all of this in. This box has seen a few miles and has seen quite a few soldering irons. I think we could all agree that that's a factual statement. She's an old girl, but the parts in here are really, they're Toshibas. So first thing I'm going to do is I'm going to blow it out real good, because as you guys seen when we zoomed in, there's a couple little flicks of solder and shit here, there, and everywhere else. Let's just go ahead and we're going to blow this out really good first. And then I want to hook it up, and I'm going to do a thing called soft key. Soft key is where we hook it up. First, we're going to see if anything arcs over and shorts out. Believe it or not. And once we determine nothing's going to short over and arc out, then what we'll do is we'll soft key it. We're just going to put like 4 or 5 watts in it, and just enough for us to get all the transistors to kind of turn on. Not enough to get the input signal into each transistor to be saturated. We just want to see what transistors are good and what are not. This style of building is really good at hiding a burnt pill. And you'll be like, oh, I've got a bad resistor here, but then no blown 10 ohm resistor over here. So we're having to go hunt for that. They said that the story I was told was this box ran great, and then it wasn't, and then they put some couple pills in it, and it still wasn't running right, and they just set it up on the shelf. So, there's the longer I look, the more solder flick I find. There is the potential of a lot of fun here. But in the same breath, not so much. It's not working right. You know how I always say, it's not my job to talk shit, it's just my job to fix the box. This combiner section over here, as we can all clearly see, has come apart several times. So we'll put that in contrast to this over here. And you see how this hasn't been soldered or hacked upon all that much? Yeah. We're going to figure it out. So, on to the next step. Let's go ahead and let's give this a good blowy job. We'll get in here and I think when we cut back, we'll be firing it up and trying to do a soft key on it. And let's figure out what's burned up. All right, so got her hooked up. We're down on 12 volts, 1,000 watt in peak, 1,000 in average 5 watt slug in reverse. Let's start up here. Shoot the glare here. There we go, now we can see all the meters. We're gonna use the Striker 955, but first thing I wanna show you is we're just talking through the box, the amp's not keyed up. Hello, audio. So we're dead keying like a watt. Let's turn this up to about halfway. So put out about 5 watts. Our pass-through tune is really high, which, okay. That's not a big deal. We make that adjustment back here at the relay, back here. So the RF comes in on this wire, runs around, goes through this arm of the relay, then goes down. Then there's a shorting wire that goes across, and then comes back down through here, and then back out through this wire. Okay? So it goes through here, and then back out this wire. If we add a little bit of capacitance right here, back to the cabinet, which we'll probably have to add another little screw and something to solder to over here, we'll be able to get the pass-through SWR down. So what we're running here, just so everybody knows what we got going on, is I've got 18.5 feet of 316 that goes from the back of the bird meter up here, 18.5 feet. And this is a nulled out piece of coax. So this represents no reactance to this circuit. We're going to look at what we got going for input, just on a dead carrier. We're going to look to see what we got for output power, and then we're going to look to see what parts are getting hot. So while we're doing that, let's fire up the old tell me what's wrong FLIR device. But let's go ahead and let's key this real quick, and let's see what we've got, if it'll even key up. Our display light's not working. The other thing I couldn't help, what I thought was really neat, is let's go down here and look. There is at least a 2 fingers width worth of space between a sub cabinet. So this amp is elevated. You see that? This amplifier sits on a little stand. Now, there are 4 fans on the cabinet that we saw in the opening segment for this video that push air down. Then the air's got to fold across and then run across the length of the heatsink. This amp, there's a sub platform that's right here, and then this big space. Well, in here, there's 2 fans that sit in the middle of the heatsink, and they add more air. And this is brilliant, by the way. Add more air to the heatsink. So you got 4 fans pushing air down, going across all the top of the parts. Then it wraps around and it's got to run down this heatsink. And then somewhere right about here, there's 2 120 millimeter 12 volt fans that pump air across the back end of the heatsink. And that's because we're running out of the ability for the air that's getting forced through here to be able to pick up enough heat or move enough air through this space to keep it cool. So their solution was to build this little riser stand and put a couple fans in here. And if you'll see, there's slots on the side, and this pulls air in, that pulls air in, and it pressurizes the cabinet to help pick up the air velocity. It's just different. It's smart, but it's different, and I dig it. Just want to point that out. Each one of these boxes that are going to be in this video have their own separate little quirks to them that I think are great. They're just a little different, so I thought I'd cover them. Okay, so the key-in circuit does work, and we've seen it make power. So we're going to turn this down as low as we can go. Let's turn the amp off. Let's go over here. So let's put about 1.5 watts in it. Turn the 5-watt slug back around. Turn the amp back on. 1.5 watts, not enough to get it to key up. Okay, so 2 watts, I bet you. Let's take the 5-watt slug and make it read forward. Okay, so 3.5 watts. It takes 3.5 watts worth of dead key. All right, maybe it takes a little bit more than 3.5 watts. There we go. Okay. So, these two transistors are getting really hot. This cap is getting hotter than frig, this one here. It's way hotter than the rest. These transistors here are not heating up at all. Those are heating up. Those are heating up. Those are heating up. Those are heating up. Wow. All 4 of these aren't working. Yeah, these 4 are dead. So now we'll come back here and we'll take a look. That resistor's getting hot. This resistor's getting hot. That resistor's getting hot. That one's dead. And this one here is relatively cold too. So the only one that's not all angry is this one and this one. This resistor's hot, this one's hot, and that one's hot. All right, so now what we have to ask ourselves, are the transistors really dead, or is there something else that's not allowing these transistors to work? So, like I said, input, split, RF comes here, RF comes here. This side controls this side controls this side. So this section here, this is back piece of 400. It runs around and it goes to here, which in turn is soldered here, and that's all hooked up. Okay. What's our input reflect like? It's not too bad. Let's go up here. I got my mic down here. Up to the ceiling we go. Come here, camera. Hello. And this is what it's making for peak power. Hello. 2,000 watts. We got some conflicts. So now, if we look down in here, let's go down here and look. We can see this 4-pill section's had problems before. And those pills have been in and out a couple times. And we can tell just by the quality of the solder work right? Somebody's been in here with a soldering iron on these 4. But with relative amount of measurement, we can tell that there's something wrong here. So let me dig into this a little bit more and we'll be back. Okay, so going on here, let's see if we can get this to catch it. We're looking at this capacitor here and then this capacitor here. Let me key this. See how hot this cap is getting, and you see how hot that cap is getting. These 2 parts, we know they're bad, and that's the reason that this resistor is getting so hot, and that's the reason this resistor here is getting so hot. You see that? So then now we jump sides and we go over here to this back corner. Let's take a look at that cap right there. You can still see the residue heat from us keying it before. See how hot this cap is getting? Right here. And then we'll go look at this cap over here. Just to show you that it's not false. That cap is getting hot. Like way hot. And I bet you when we go to measure this, it's bad. And that would explain why this one's getting hot, this resistor. That explains why this resistor here is getting so hot, is because of these caps. Now from the outside, we can't physically see any difference. This whole section here, this resistor is getting a little warm. But that's because these transistors these 2 are working, but these 2 are not. So we got to go figure out where the imbalance lies. But we do know for a fact that this capacitor, this capacitor, this capacitor, and this capacitor are kaput. So we change pills till we're blue in the face. But if the output caps, which these are notorious for getting hot and devaluating, go bad. Now, the customer brought up a big giant bag of 1,000 puff metal clads. I would feel much better about things if I just went in here and I changed out these 6 caps to metals and these 6 caps to metals, and we went on with our day. That's just me, it's my opinion. It's probably what we're going to end up doing. Still, at the end of the day, we got to take this apart and figure out what's not going on here. I just want to look at it. But see, the more and more I look at this, the more little flicks of stuff I see. So here, let me give you an example. So can we see that from here? You can't. Let's keep going. That's a washer. See a little round thing that's right there? Right there? It's a washer just hanging out, floating around inside the box. Is this the most efficient way to build this? No. Is it going to work just fine if we get all the little bugs worked out of it? Yes. So at the end of the day, you have to reside yourself with the idea. Like this whole, I was explaining this to the guys that brought this up. This whole system of delivering power is very inefficient. These 4 pills and these 4 pills get a majority of the current. They're drinking from pretty much an unlimited well because the wires come in, okay? These 4 transistors and these 4 transistors get a little bit less voltage and a little bit less shmoo. And these all the way down here on the end are getting starved out. So the idea is that you just provide a big enough piece of wire to carry enough current for the whole circuit, and each part just pulls enough out of it that it needs. It doesn't really work like that, but it does work like that. This piece of 4 gauge is technically, in theory enough. What we do today, since we've read the RF, Motorola Engineering Hand Guide, we would do a single piece of 8 from here, another single piece of 8 from here, another single piece of 8 from here, another one from here, and another one here. And that allows, and then we'll pull all that outside the box and we sum that together outside the cabinet. And the reason we do that is so that each particular section has the same total amount of ability to pull from the same circuit. It works better than this system here. It's the reason everybody jumped over to that about 10, 15 years ago. So, okay. I want to pop these caps up. Let's test these. Let's test that one and test that one and that one and that one. So I'm going to measure all these caps. I'm going to replace them anyhow because the results are a little shocking. But let me make sure my lens on my camera is clean. Instead of trying to pick this up and show you, I think what I'm going to do is I think I figured out why this section's not working. Make sure both those pictures came out. They did. Okay. So I'll insert those photos in here. Down here is a finger of schnot coming from this side of the transformer going right to the case. Right down short and out to ground. So when I saw that, I went, okay, I'm pulling all of this apart. I'm just going to take this all apart anyhow, and we're going to start at this end, and I'm going to get out 3 pounds of solder wick, and I'm going to clean all this up and clean all these out, and we're just going to start over. We're going to reflow everything through here. Then we'll come back and we'll test all of these capacitors, which these things are absurdly large. These are 10,000 puff. Look at that number. $10,000 picofarad. Okay. We'll rebuild all of those and clean those up. But I want to test each one of these. So I've got these 3 pulled up. Let's see if memory serves me. This is the one that's in question. This is the one that's in question. This is in a 900. This is down in the 800s. And when I saw this one, which wasn't showing up as a defective part, but it's all the way down at like 880, I figured we'd pull all of these and check them. So let me get set up for that. Okay. $986. It's supposed to be 1,000. $838. It's supposed to be 1,000. $898. 895. It's supposed to be 1,000. $12 picofarad. $13 picofarad. $341 picofarad. 12, 3, these are supposed to all be 1000s. So we're going to assume that all of these have gotten a lot of damage as well. So we're going to run with this a little bit. Let me get in here. Let's get this cleaned up. I'll get all these caps pulled off. Then I'll flip the amp up on its side. I'll resolder the face of the transformers. Then I'll flip it back up on this side. And I'll resolder all the faces of these transformers. Then I'll rebuild all the flybacks and straighten out their legs and resolder everything and make it so it doesn't look like chicken poo. And we'll put some 1000 metals in here. And then we'll put this all the way back together. I don't think these transistors are bad. I think that this input circuit over here being shorted out and this cap being so borked off. If not, we can always take this section apart, but I'll know this is all correct. All right. So, I mean, we're going to see heating in the rest of these resistors because this whole section isn't right yet. Give me time. We'll get there. Well, let me pop these off. We're going to assume that all of these are borked and we're just going to replace them anyhow. We're not going to go through this painful test process. So, yeah, let's get with it. Okay, everybody's set. Everybody's got their beer. They got their cooler to sit on.
Yes, sir.
You got air conditioning blowing on you.
Oh, man.
You're not in Tulsa anymore. You're in Boise, Idaho. All right, guys. So I got the boys with me here. Can I tell you who you are? Can I tell the world who you are?
Absolutely. Yeah.
Okay, so you are
447.
447 and the legend Stormy Weather. Which, I'm sorry, dude, is a stripper's name to me. You know, kind of like Vajandria or Latasha. You know, your stripper names, you know what I mean?
Mm-hmm.
Anyhow, they were at the hotel taking a nap when I was working on this earlier. So we've got this half of the amplifier pretty much rebuilt. Like I said, we went through, we washed it and did all that kind of stuff. Got all the bad sloppy solder work out of it. So now we're going to go over here and pull all of these out. Of course, we're going to test them so we have it for a record on video. But A, B, A, B. Like I was pointing out to the guys here, I was pointing out that this is the most amazing amp I've ever seen. Because most amplifiers are going to either have the messenger style of combining, they're going to have the Dave, Mave, Fat Boy, whatever style of splitter and combiner. This has literally all three. The input side's all made up in 2-pill sections. The output side is made up of 4-pill sections. And then we've got 3-port combiner going to a single common port combiner, 2-to-1. This box is amazing. Okay, so let me flip this around. We're going to rip this all apart. We're going to make that side look like this side. Then we'll flip it back around, and when we come back, we'll actually soft key it and see if these transistors are now lighting, and we'll see if we got any imbalances. And then we'll work the problems out from there. Just had fun teaching the guys about lithium battery technology. It's so cute, you get busy talking, and the next thing you know, 3 hours have gone by and nothing's gotten done. It's crazy. Okay, so this is the other set of 1000 puff caps from this side of the box, which we replaced with all matched metals. This one cap is testing at 719 and it was supposed to be at 1000. We'll set that out there so you guys can see it. This one tests at 598.7. Supposed to read 1000. If you're going to open the cooler and get a beer out, open the cooler and get a beer out. He's trying to be all quiet and sneaky back there. This one reads 423.7. 424. You see why I didn't jump on doing the input tune on this box, guys, in YouTube land? This one reads 557. This one reads 779.6. So far we've discovered all but one of these capacitors. 465.7. All but one of these capacitors on the output circuit was bad. Just some were worse than the others. So now that we've got good solid solder work, and we've tested all the caps on the input, we've tested all of our flyback capacitors, and we know that all of our output tuning capacitors on the output transformers are all stable. Now we can repeat the test from a few minutes ago with the soft key. It's the wall outlet we see as heat. There's no heat here. Okay. I'm going to turn the amp on. Hello. Now we're running. All right, so we have any heat? Let's see, are these transistors up here turning on? They are. These transistors up here are working now. Look at that. And well, let's look at our output network. Look at how quiet and cool everything is here. Nothing's hot. These little see, look, I put my finger in there for heat reference. Nothing's hot. Hello, audio, 1 2 1 2 1 2. If we would have heat, it's going to show up here on these resistors, right? As imbalance, we have nothing. None of the caps on the output network are hot. None of the input caps are hot. Nothing over here on the balancing network is now hot. So everything's in balance. We didn't have one blown pill, but we had a pile of bad caps. So now, let's go over here and we'll turn our voltage up a little bit. Come up to about 15.4. Let's see, which way can I move this so you guys can see the voltmeter? Here, there we go. Volt amp meter over here. Now we're going to hit this with about 150 watts of drive. Hello, audio, 1 2. Now we're making 3,500 watts with 180 watts of drive. Peak power, and we're making about 400 or 500 bird. Pretty freaking cool in my opinion. What does have me concerned is how the fans inside this amplifier almost stop. Listen. Hello, audio, 1 2 1 2. This 24 pill is amazing. This thing's amazing. Pardon me, I misread the scale. I keep thinking I'm in 5x over here. We're not. So we're making 800 and some watts with a couple hundred watts on the bird meter. So now, let's go over here. I gotta move you guys back over here. You're in the way. Sorry, YouTube, you're in the way. Let's tune down our input. Hello. Nope. Hello. Really not happy. So now we went with this meter almost pinned over in the corner to almost no input reflect. I think I need to get another amp out to drive this thing. What do you guys think? Let me go grab, let's say the bench 4 pill. Let's hook it up.
It's run efficient that you can't make something do what it's not doing.
So here's where we're at, y'all, in YouTube land. Nothing in this amp is getting hot. The input reflect is way down low. Anytime I go and I hook up any of my comp radios to it, the Striker or the Cobra 29 from Derail, they would make huge, demonstrously large bird numbers. is starts squealing like a hooker in church. And the driver or the radio is what starts squealing. And it's because we got the lid off. Now I'm going to run this. I'm hitting this with my Stryker SR490. Let me turn the 24 pill off. Let's go over here and let's take a look. So this is in 5 times. So the 10 is 1,000, 20 is 2,000, 30 is 3,000, 40 is 4,000, right? Hello, 1, 2, 1, 2. We're making about 1,100 watts worth of drive. This meter here is a 1,000 watt slug. The 490 still got all the limiters in it, and it has not been derail modified. Hello, audio. So, hello. You can see it wants to do more average, but the limiter pulls it back. Hello. So we're putting 100 bird in it. Let's turn on the 24 pill. Now I'm going to say right now, I apologize. If you are listening on headphones, turn the volume down. Or you know what? Let's back this way. Let's back this way away from this amp. And maybe we can minimize the blast that's going to take place. The RF is going to get into the microphone, so just understand that going in. Ready? Hello. We're seeing a whopping 400 bird. Hello. And over 4,000 watts peak out of this 24 pill. The harmonics that are coming from these 3 different styles of combining are breathtaking. It is wiping out my volt amp meter over here. It's making my computer on the workbench flip out. You guys should see the receive side of the radio over here, behind me over here. But I've got this. This is my finger. Nothing in here is hot. These are my output combiner resistors. They're all ice cold. And over here on the final stage, combiner resistors here are all ice cold. The ones going through the final combiner, they're all ice cold. So all we needed to do was change out to get this working. Let me show you this. Because we had to change every single one of these caps because they were all bad. And then these way too small a KVA caps here, these were all bad, and that's part of the tuning network. I'd like somebody to explain to me how 3 150 3 kVA caps plus 100 puff doorknobs, so these are 150 puff a piece, we arrive at the same place with an additional 125 picofarads worth of tuning capacitor in the back. I think those caps have been bad for a long, long time. The guys here are happy. This box is running way better than what it's ever. How long have you had this now, Stormy Weather?
Probably 10 years.
10 years. How long has this thing been sitting on the shelf?
I'd say probably 7 out of 10.
7 out of the 10. All right. So we'll call this a win. We're going to move on.
Yes.
Okay.
Sir.
I'm going to button this up, put the lid back on it, and we're going to move on to the next amp, which is a 32 pill.
Yeah, 32 pill.
This is their baby. These guys love this box. They want it to run more than anything else. So not this one, the one that we're going to put up here next. So let me reset the bench. We're going to put a bunch of stuff away, put the lid on this thing. They're going to get it out of here so we got a little bit more room to breathe. We're going to have to consolidate that 96 pill. This is screwing me up that there's no room to move over here. All right, gentlemen, we'll be back. Okay, gents, so here's amplifier number 2. This is a 32 pill bill, or 32 pill. It says Boss, and then it says 7,000 plus on the front of this thing. That's all the information I have on this. I don't know who built it. This amplifier is in far better shape than the other amplifier. It's got a positive bus system that we're all kind of more familiar at looking at. 32 transistors in here. The combiner and splitter circuit is actually, it makes a little bit more sense. Yeah, it's got all the right parts kind of in the right places compared to the other two that are here. Hopefully this will be a little bit easier of a fix. The only thing I've done that you guys haven't watched on camera, but Stormy and his brother were here, I sat here and I resoldered every single thing inside of here, down the transistor traces. Who'd ever been in here before me made this look like chicken poo on the inside. So I went back and I reflowed everything that was in here and redid all of it, because the pills that have been in this box apparently have been in and out several times, which that's fine. These guys love this amp. They have a lot of deep felt affection for this thing. So the story with this goes is it had a couple pills go down, and then they sent it to a friend of theirs, and when it came back, when it left before it broke, they were able to dead key 10,000 with this bird. And then it would fall back, if they would maul the box, then it would fall back to about 8,500 or 8,000, somewhere in there. Which, okay, that sounds doable if you're on an 18 volt, 19 volt system, something like that. I mean, it's not the way that you ever want to run a box. You ultimately, what I was explaining to the guys is you don't want to maul the box that hard. It'd be better if you keyed it at about 5,000 or 6,000, 5,000, somewhere in there. You got to think that each transistor is good for about 100 watts, 150. So 150 max, maybe 125. Each transistor is good for about 100 watts worth of dead key. And that's at 12 volts. At 18 volts, you can figure the things, you know, at 12 volts, that means the max dead key on this would be about 3,200 watts. At 18 volts, that number changes dramatically, okay? And it goes way up. It goes way up. So, you know, 5,000, 6,000 dead key is not unheard of in a 32 pill world on 18 volts. Now, how long is that going to last? I don't know. Just saying. But back in the day, when the Toshibas cost like $10 a piece, that's the way the guys used to run them. Now, what I can't help but notice is that this has got a 5 and a 5 wrap. 5 wraps on the input, 5 wraps on the output. Now this box won't do anything past 3,000 watts at all. At all. And they're like, man, we'd love to have this thing back up running like it was. I don't know if we're going to be able to get there or not. I know with the 5 and the 5 wrap, 330 and 1,000 is not the way to go. If this was 3 and 3, 3 and 3, then 330 picofarad and then 1,000 puff would be appropriate. But with 5 and 5, according to the old school techs like Foxy and them, what we should be looking for is 330 and 680. Okay, so got a bunch of 680s here. We might end up trying that. In my mind, when I think about it with some of the boxes I've dealt with, what we want to have is 1,000 here and 1,200 puff here, as I look at all my notes. But for the time being, the only thing that we want to establish is we're going to soft key this thing and we're going to see how it's running. Now, it's got this variable on the output. This is for output, by the way. This solid rod here goes past this section here and then goes up to the actual relay. So the way this combiner works is a little tricky, but this is our output and this is attached to our output. Where the two are summed together, pre the combiner transformer, there's 100 puff, 100 picofarad, 15 kV doorknob that's here. This is our input tune, is this doorknob here, which is 100 puff. The input on this is going to be a little rough. I can tell that right now. Before I even key anything, I know the input on this is going to be a little bit rough. The reason for that is, once again, we're dealing with some hybrid technology here, okay? In the day, they would use different length coaxes because there was so much coax involved inside the cabinet. So the driver coax is going to be a little bit shorter. My non-reactive resonant length piece of coax that goes between my bird meter and this amplifier is not going to be ideal for the way this input network is set up. RF comes in, goes through this relay, and then goes down through some RG400, and then goes out to a bunch of more RG400. The problem is there is not a single drop of capacitance past the splitter circuit to help compensate for the impedance bump. And the other thing is, it is completely physically decoupled through capacitors. The RF comes in, gets supplemented as our input tune on this doorknob, but then it is isolated behind this transformer. The splitter splits the signal, and then we have these decoupling or coupled capacitors. They're actually in line, in series. So 100% of the input RF goes through these caps and then goes out to the rest of the amplifier. We can use this to change a whole lot of principles inside the amp. Nobody does this anymore. But from that point on, where I'm going with this long drawn out story, is there's no more capacitance on any of the other stages. It's 50 ohms and we drop back to 100, and it's not compensated for anywhere. Normally we'd have capacitors here, a capacitor here, and a capacitor here, another one here, and another one here. This is like a Texas Star combiner intermixed with a whole bunch of messenger style of combining. If we wanted this to be our only point of tune, we would remove these capacitors and make it straight pass through. So this would go straight out. We could move this combiner wire and go here, and this combiner wire and go here, and then we could use this here as our point of reference to compensate for the impedance bumps. Okay. We're just going to key this and see how this goes. And now that I made that big long speech, I notice there's this disc capacitor here that is supposedly compensating for the input impedance bump from here to here. But then after that, there's no more capacitance. So it's unbalanced at 100 ohms after that point. So let's go ahead and let's soft key this real quick. And the only thing I'm looking for at this point is to make sure all the transistors are lighting up. Got two dead ones. Yep. Right here. These two are dead. They're not making any heat. Meanwhile, everything around them's getting hot, and this combiner's getting hot. These two transistors are gone. Or there's something pulling them to ground. So I'm ready to be done for the day. I kicked the boys out of here. I just needed a quiet moment. Pull a Sharpie mark on those two transistors. I kicked Stormy Weather and his brother out of here for the hot minute. And I just needed to have a quiet couple minutes to take a quick look at this without them being around. Let me fire this back up one more time. So we can see that combiner resistor's hot. That one is hot. This one's less hot. Of course, then there's no heat over here. But I take that picture. Playback. So you can see right here by the hash mark. That's a transistor, that's a transistor, that's a transistor, that's a transistor. These two right here, dead. That's the balance resistor and the other balancing resistor. So we know we got a couple dead holes. That's okay, these boys came to play. I'm not kidding you. Right now, he's probably got the largest collection of HG transistors in the United States. He's got 4 brand new boxes of HG transistors with him at 100 per box, or 250 per box with him. We're not going to talk about all the Toshibas. The only one that's probably got more Toshibas in stock is me than him in the United States right now. I mean, he's got a crate over here full of parts. But something here is either pulling this all to ground and not letting this turn on, which I'm going to look at tomorrow because I'm tired. I'm ready to be done. And I've found that working late nights and being tired causes more problems than anything I'm able to achieve and fix. So it's time for me to fold up shop. I'm going in the house. Gentlemen, I'll see you guys tomorrow. Appreciate every single one of you. I'll be back. Oh, good morning, everybody. Okay, so here we are 8.5 hours later. Whew, I slept good. Let's see, I think where we left off is that I need to go over here and attack these 2 transistors that are not working. So let's do exactly that. And then I've got to make 32 flyback harmonic suppressor resistors, because I bet you guys didn't even notice that there are none in this box. We are going to remove all these 1000 puff capacitors and we're going to replace them with 860s or 680s. I just have a feeling. La, da, da. I'm high on this feeling that it's going to run better that way, especially with the 5 and 5. Me and Foxy agree. We had a conference call last night. Anyhow, let's get this section running, then we'll go do the rest of that crap. We'll be back. So this has turned into a day of confusion for me. So there's this 100 puff doorknob in there, and I took it out. It didn't make any effect on how the output tuner works. So I focused on just trying to get the input tune down. This box does not want to run. Straight up, does not want to work. Period. Does not want to work. Period. I don't care how many volts I put it on. I don't care how much drive I put into it. It will not do anything more than 3,000 watts peak and about 2,000 watts bird. Won't do it. No matter if I hit it harder, I turn it up to 17, 18 volts, I turn it back down. It's stuck. So I decided that I would just focus on getting the output tune as close as I could get it and getting the input to actually be flat. Over here is a 50 watt slug that I have set up in reverse for my drive stage. Even running it on radio drive, I could not get this thing to get down below 10 watts worth of input refleg. It has a problem. Well, I don't see any of the stages heating up. I don't see any of these getting warm anywhere. Please note on the output side we've got 2 watts, okay? There were no balance resistors here at the final stage combiner. So I start going down the list of different things to check, and I start counting the number of turns on the combiners. This combiner has 6 turns. This one has 7. This one was here, that one was over here. That was causing a little bit of an imbalance. So I went ahead and flopped them around. I'm going to redo this. In the process of elimination, because this is a 5 and 5 turns, so there's 5 wraps here and 5 wraps here, I have tried the classic 680 and 330. So 680 here and 330 here. I have tried 680 here and 1200 here. I've tried 680 here and 680 here. I've tried 1000 here and 1000 here. I've tried 680 and 1200, and that's through this whole box. And never once has this box allowed itself to make any more power than 3,000 watts. So something has gone wrong that I'm not able to test for, or not looking or thinking about I need to test for. So this is where we start getting down into the nitty gritty of the grass. I had a tuner clamped to the front of the cabinet and a big long piece of wire running over to this thing. So I just went ahead and I mounted up an input tuner and said piss on it because it was so sensitive. I couldn't get it to lay down any other way. I had to add a bunch of inductor to it, and there was a 100 puff doorknob routed through a piece of coax. Now I was getting unbelievable harmonics out of this box, like wicked harmonics. It was screwing up my computer. It screwed up one of my cameras in my security system. It was making the front end of my receive radio over there that's sitting on the shelf go nuts. Well, I gotta stir my soup. So when I started playing around with the input to try and get the input to not be so whacked out, I disconnected that 100 puff doorknob, and all of a sudden all the harmonics fell out. Now the doorknob is fine. There's a resonance issue that was taking place between the doorknob and the input network. Well, this particular input network that's in here, which is subject to change. Everything in here is subject to change as long as I can get it to work. There's a 50 and a 25. So there's a total of 75 picofarads worth of fixed capacitance here. This wire represents 15 or 20 picofarads, and of course it's running in parallel with our output transmit line, which that's its own separate nightmare. This Johnson air variable that I put on here for the input tune represents, I think it's 20 through 100 picofarad. So when I apply 100 picofarad here, it's too much capacitance, but when I apply it through the variable, I can get it down to where I've got 0. And I mean like a quarter of a watt worth of reflect with a kilowatt going in. So the problem is the kilowatt going in is only producing 3,000 watts. This box is pulling a tremendous amount of current. We're talking 600-700 amps. The harmonics were so bad that it was wiping out my volt amp meter. RF was getting on everything everywhere. There are 104 disc capacitors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of them on the positive rail. Positive rail is not separated. Positive rail is attached to the back of the output transformers, which is okay. I've seen plenty of boxes run like that. 5 by 5. 5 wraps, 5 wraps. 5 on the input, 5 on the output. These 1,000 puff clad caps have been off and back on, and it runs the happiest with it having 1,000 picofarads here and 330 here. I've tried every other combination that there is. So now what I'm going to do, and I can't believe I'm going to have to do this, something in here is radically changed, and I have to get my Unihenry meter out, and then I'm going to start measuring each one of these chokes, to make sure that we don't have a problem with that. And then I got to go over here on the input and do the same thing. Measure here, and then I'm going to have to start measuring each one of the... It's not showing up as heat in any of the resistors. I can sit here and run this thing, and run this thing, and run this thing. The RF's not backing up to here, which is our final stage combiner. It's not backing up to here, which is our next layer down in combination. It's not showing up here, or here, or here, or here, or here, or here. RF's going in. I got great input reflect. But you know what they say, with enough inductor and enough capacitance, you can tune a fence post. Doesn't mean you're going to be talking that well. Something is keeping this box from wanting to run, like straight out. And for the first time in a long time, I'm a little confused. So I'm going to eat my little cup of noodles. I'm going to sit here and listen to an episode of Archer on the computer play behind me, and I'm going to sit here and think about this for a hot minute. But I have the feeling I'm going to have to jerk out the old inductor meter and figure out what's going on. Please keep in mind, this amplifier has been to some of the biggest techs in the United States already. I'm not going to drop any names, but from some of the biggest of the AC guys down to this thing has been to probably, I think, 7 different people before it came here. 6 or 7. And I'm not exaggerating. Before it came here. This thing has spent the last 4 years on the shelf because they didn't think it was fixable. So if it don't work when it walks out of here, okay, I lost a day or 2. But you know what? I'm going to give it an honest whack. The transistors are all good. They're operating. They're consuming amperage. They're making RF power. There's something in this that's eluding me. I mean, there's a lot of disorganization, bad coax connectors and that kind of stuff that don't, I mean, everything's working. It's not minty mint. And have faith, if I do manage to get it going, I'll put brand new connectors in there. But I just, for the time being, I'm simply saying, BBI is a little confused. Give me a minute. I'll figure it out. I think. Maybe. So we've decided that we're going to nickname Stormy Weather Mrs. Stormy Daniels at this point. And that's all because of his brother, by the way. So none of this gets put on me. I get to walk away clean. So Stormy, I hate to break it to you, buddy. You're now Mr. Stormy Daniels. The boys are back over here, by the way. So I finally cracked the nut. I figured this out. Bad design. Like I was explaining in the last segment, before the guys got here. How many different technicians have been in this? 4 or 5 different people at this point?
But, yeah.
Okay, hold on. Say it again. How many?
About 4.
Yeah. Okay, and we're not going to give any names because, well, it's not my job to embarrass the innocent and make fun of the. It's just not my job, right? My job is just to fix the box. So, what I figured out is that, oh man, what did I do with my demonstration piece? Oh no, I threw it in the trash. Hold on, everybody. I threw it in the fuck it bucket. Hold on. Oh, goddamn. Okay. So, what we had going on here was a failure to induct here. They had this hard piece of mag wire, which is impressive, by the way, that's used. Somebody straightened out. They pulled out of a transformer or something someplace. And they go in from this tuner by this pad. And then directly on here to the relay. Well, it was about that much too short. Right? So then they went and they compensated for their inadequacy by stacking big doorknobs on it. So we snatched that out of there. I got to thinking, I'm like, well, it can't be a capacitance issue. I got all the capacitance in the world I want to add to it. It's got to be an inductor issue. So we've got our combiner network, and this one trace that comes through here is one constant piece, right? Through here is one constant piece. So I grabbed up on this side, and then I tapped an inductor. So I wound an inductor for this thing, and I tapped it. Now what's here is a piece of 50 ohm coax that runs over to the relay. But now we gave the circuit what it wanted to be resonant for the output. Okay. So we went and found what it needed for the frequency. And then we back over here, we tied in this tuner. We had to do the same thing on the input network. We had to tap it, we had to create an inductor coil and tap it down into here. And then we put doorknobs to complement this tuner. So over here, we've got ourselves a 50 watt slug in reverse, and we've got our fluke meter on the ground. Over here, we have a 5,000 watt slug, or 1,000 watt slug in 5 times, so 5,000 watts peak here, 5,000 watts going forward and average, and a 5 watt slug in reverse back from the Bird 10,000 watt dummy load. Let's see, what do I have hooked up over here? The 490. Okay, so let's hook the 490 up. Now, while we were here with Mrs. Stormy Daniels' amplifier, we went ahead and we replaced the coax connector here, and we did the output side. They were so slopped out you could literally jam your thumb in the hole and bang it like a hot dog down a hallway. It's pretty rough. So we went ahead and put brand new Teflon connectors on here, all brand new mounting hardware, brand new ground lugs. Got Teflon wire coming here and high temp, high strand count, beautiful, wonderful stranded wire for the output side. So it should last forever. We're going to redo this remote pedal and stuff. I'm just trying to show this thing working so I can move away from having this on my workbench for a hot minute. So for right now, let's see. Turn the amplifier off. Hello, 1, 2. Let's bring you over here with us. Hello, 1, 2. So we're putting about 1100 watts into it. Remember, 5,000 watt slug. This is a very low bird reading radio. Hello, 1, 2, 1, 2, 1, 2. Okay. By the way, I want to warn you, if you're wearing earphones, RF's going to get into the mic. There's nothing I can do about it. But, hello, oh no, wait a minute. It helps if I plug in the amp. Please note the wires that I removed off the coax connectors. This is 14 gauge home Romex. 4 other technicians didn't look at this and go, oh, that's wrong. Just so you know, to the 4 other guys that are probably going to see this and went, wait a minute, I was inside that box. Yes, you epically failed the customer because you never use solid wire going to an outside connection. The solid core wire will break every single time. This is their idea of a good connection from the relay. Well, we replaced it with stranded, high temp, heat resistant wire that can do the job. Okay, so amp's plugged in. Oh, over 5,000 watts plus on the peak side of things. I cannot tell you personally how excited I am to see that. Well, because I sat here and I ran a voltage to the moon trying to get this thing to do more than 3,000 watts, and I don't care how much drive I put in it, it wouldn't do it. Just wouldn't do it. Currently sitting around 15 volts. Hello, audio. Pulling about 237 amps. Hello, making around 1,000 bird. So now what I was telling Stormy Daniels was that I'm never going to let that go, Stormy. I just hope you know. What I was telling Stormy Daniels is that this Striker 490, Striker 490's got all the mod limiters in it and stuff, and it doesn't do dick for bird, right? So now let me grab up my derail Comp 29 and plug that in for you guys. And we're going to notice this thing produce way less peak power and almost twice the amount of bird, if not a little bit more. Okay, derail comp radio plugged in. So let's check this out. Let's zoom in here. And now we're looking at the average meter, bird meter, RMS meter, whatever you want to call it. I call it bullshit because bird does not even recognize this is a form of measurement on AM without a peak kit. But, hello, 2,500, no problem. But look at the peak numbers. Hello, we're down to 4,000 watts. But almost twice the bird. And instead of putting 1,200 watts of drive in it, we'll turn off the 32 pill. Hello, 1, 2, 1, 2, 1, 2. Putting 600 watts of drive in it. It's amazing when a radio can change your bird numbers by double with half the drive.
Wow.
I'm trying to explain that to these guys. They're big watt chasers. They like to maul stuff too. Yeah, we'll make that key 10,000 and it only swings back to 6. I'm like, what? Wait a minute, what? I say this in jokes. I absolutely, I love my friend Stormy Daniels over here. He's a good dude. So, here's the difference also that I want to show you. This is the derail comp radio. Hello. I gotta turn the amp on again. Hold on. Whoop. There we go. Derail comp radio. Hello. About 370 amps. Now, we'll hook up that Striker 490 again. Watch what it pulls for current now. Come on. Mic clip's getting confused. About 240 amps. So we shaved 100 amps worth of draw off the box, and we're making 1,000 more peak with the 490 hitting it. So now, let's go over here and let's take a look at the bird meter. I gotta get over here. Oh, excuse me, everybody in YouTube Worldler land. Audio. Says 1200 going in and about 4.5, maybe 5 watts worth of input reflect. And when this box came in here, that would have been about 80 watts. So now, the other thing I want to show you is we went ahead and we did some work down in here, and we played with the pass-through tune. Pass-through tune, as I was explaining to Stormy Daniels, is pretty important because it works on both sides of the street. Not only the RF passing through the box, but your receive RF. So we added some capacitance here. Now, as we all know, the international trucker standard is the 955 SWR bridge. The bane of every amp builder's existence, because as soon as you give anybody a meter, all of a sudden they're an expert and they'll call you up with this silly question every frickin' time. But when I turn the amp off, I have a flat SWR, but when I turn the amp on, it goes up to 1.2. That's a problem, isn't it? At 1 2 1 2 1 2. As we can clearly see, at 1 2, radio's at full output and RF is passing right through it with no problems at all. At 1 2 1 2. Radio's happy, amp is happy, pass-through tune is happy. Stormy weather, are you happy?
I'm happy. I'm good.
Okay. Are you grateful that I just called you Stormy weather and not Stormy Daniels?
Hey, you notice I answered then, right?
If you say so, Miss Stormy with Daniels. I totally get it. Okay, so what do we got to do to bring this to conclusion? I guess we got to put the case on it.
Yes.
Now, how much of this do you want me to really clean up? Do you want us to do all the fan work while you're here? Okay, so now we got the lid on it. Hello, 1111, hello, 111111111111, hello. It's not killing my freaking voltmeter anymore. Computer's not tripping out. Looks good on the radio. Hello, audio, 11111111111111. Hello, 111111. Fans are staying turning. Hello, 111111111111. Did you just hit that million proof shine again?
No,
I got a bottle of the corn squeezins out here that I make. And Ollie, Stormy's brother here, he's been sipping on that all night. Hello, 111, hello, 111111, hello, 111111. I can't stand, like I was telling you guys earlier, I can't stand when I watch other people test a box, and they don't want to stand on it. It's like, hello, hello, oh, it's working. See, hello, hello, it's working.
Yeah.
No, man, you got to stand on it and talk for a couple minutes. Dead keying a little bit more than 1 or 2 watts. Hello, audio.
What's that needle doing anymore?
What needle?
That needle don't know. That output needle.
I was hitting a 5,000 watt stop peg and stopping. So, but all joking aside, Stormy, it's been a pleasure having you here, but I think we're going to call this a wrap on this one. What do you think?
I say good. I say good.
Gentlemen, you sat here and watched this train wreck, I mean, amp repair show now for over an hour and a half. And I got to tell you that I want to thank you all for hanging in there with me. I give a big shout out to the Patreons down here. And I just want to say thank you to all of you for following along and tuning in. And I mean this sincerely from the bottom of my heart. I appreciate every single one of you guys. Stormy, thank you for coming and spending the last 2 days with me.
Absolutely.
Now we just got to fix that other giant train wreck. Is this thing blue or is it black? I know it's got a AAA sticker on the front of it.
I can't. It looks dark green to me.
This other amp he brought up here for me to work on is so big that 2 people have to pick it up. How many pills are in it?
96.
Video on that's to come. Gentlemen, I'll see you. I got to run. Appreciate every single one of you. I'll see you. Click, click.